Hello, and welcome to your lesson on group comparisons, part 1. In this video, we'll be looking at the Mann-Whitney U. The Mann-Whitney U requires us to have one variable that has two categories, and the other variable that is at least ordinal or better in that it's interval or ratio. Generally, you want more categories, but if there's not, there's a mechanism for tie corrections for values that have a lot of ties. In the case for some ordinal variables where there's few values or few categories. So in this instance, let's start out with the hypothesis. Now, for the Mann-Whitney U, you can propose a one-tailed or two-tailed hypothesis. In this instance, let's propose a one-tailed hypothesis. Let's look at people who've been chosen to serve on a jury and how the income changes between them. So in this instance, we have a variable actually chosen for jury. Here the answers are 0 for no and 1 for yes. We also have the income variable. And notice here that the value is none, which means the number stands for itself. It says approximate family income for last year in terms of thousands is what this is actually. So the first thing we need to do is look at both variables in and of themselves. So let's run a frequency distribution. So this is a univariate analysis. So I'm going to go to my descriptive statistics, run a frequency distribution, and choose actually chosen to be on a jury and approximate family income. I'm going to go to statistics here, click that button, and I'm going to choose my measures of central tendency because I'm dealing with one nominal level variable with two categories, and one approximate family income would be a ratio level variable. So I want to see skewness and kurtosis, and I also want to see the standard deviation. So I click continue in this dialog box here. Now I want to see the charts. I'm more interested in the charts and the histogram for the approximate family income than I am actually chosen for jury. So I'm going to click continue. Display frequency table, yes. Click OK. Wait for the output window to generate. So notice it gives me the descriptive statistics box first. And what I'm really interested in here is the mode for the actually chosen for the jury is 0. So that means that most commonly people were not chosen for the jury because no was 0. But if you look at approximate family income, notice the mean here is 35.69. The median is 30 and the mode is 40. And notice that little A, little superscript for the mode. There are multiple modes that exist and 40 is just the lowest. So when I look at the skewness and kurtosis for the income, I see that it is positively skewed and highly leptokurtic. So when I scroll down to the histogram, you see that, and there it is, highly leptokurtic, and that there's a few outliers that pull the mean and the tail off to the right. So this is a very positively skewed distribution and a highly leptokurtic distribution. So in this instance, it doesn't meet the assumptions of a t-test, but we can actually use a Mann-Whitney U as an alternative to the t-test. And so that's what we'll do here. We'll use the Mann-Whitney U as an alternative to the t-test. We could actually analyze other ordinal level variables equally as well with the Mann-Whitney U, but we can use it as an alternative to the t-test. So let's go about graphing the differences between the groups. So let's see if there's really any difference in the means when it comes to have you ever served in a jury or have you ever not been chosen for a jury. And so I'm going to go to graph here. And I'm going to choose legacy dialog. I'm going to choose bar graph. When I get the dialog box here, I'm just going to click simple. Make sure it's outlined in heavy black lines. Click define. So I'm going to choose my actually chosen for jury. That's going to be my category axis. That's how many bars I'm going to have. Remember here that 0 is no and 1 is yes. And then I'm going to choose approximate family income. I'm going to highlight it. And notice I want to put it right here, but I can't right now because number of cases is selected. What I want is other statistic selected. And I'm going to choose approximate family income. I'm going to leave it at the mean because it is actually a ratio level variable. So I'm just going to leave it as the mean right now. So I'm going to click OK. SPSS generates the output in the bar graph. So I'm going to double click here so I can see the values of the bar heights, what the exact values are. And when this chart editor appears, I'm going to click on the Show Data Labels button. And just click Close. And it shows me the exact means for each group. I click Close. And I notice that the people that are actually chosen for juries make more money than people that are not chosen for juries. So the question becomes, is this difference significant, or is it just due to chance? To answer that question, what we need to do is perform a test of significance, and in this case, the Mann-Whitney U is our best option because the data is so skewed for the dependent variable for the income. And in this case, we would make the hypothesis, if it's a two-tailed test, you would say there's a relationship between being picked for juries and income. If it's a one-tailed test, so let's go ahead and make the one-tailed test hypothesis. So let's go ahead and make the one-tailed hypothesis. People who are picked for jury service make more money than people who aren't picked for jury service. So now we're going to test to see if that relationship is real. So let's actually go with the one-tailed hypothesis here. So to get your Mann-Whitney U, you focus on Analyze, and you come down to non-parametric tests. And notice here there's a Legacy Dialogues box, and that's the one you want. Legacy Dialogues. Then you go off to the next pop-out menu, and you scroll down to the 2 independent samples. That's what we have here. We have 2 different groups, picked for jury service and not picked for jury service, and we're comparing income, or household income, or family income against those 2 groups. So I take my actually chosen and I move it into the grouping variable box, and notice that there's these 2 question marks here. It's asking me to define the groups. So I just go in to click the Define Groups button. I pick group 1, which was the no group. They were coded as 0, and the yes group was coded as 1. So I click Continue, and then I go find my family income variable, approximate family income, and I move it to the test variables list. Notice here there's an options box. If you want, you can request the descriptives or the quartiles if you choose. I'm just going to leave it at descriptives and click Continue. Notice here at the bottom of the dialog box we have 4 different tests to choose from, and the Mann-Whitney U is the one that I want, and it's default checked. If it's not, make sure that it is. Click OK. SPSS generates the outcome in the output window. And notice the first box is the descriptive statistics box that I requested. It tells me the actual mean of the variable, 35.69. And notice that the Mann-Whitney here doesn't compare actual means. It compares the mean ranks. So every income score is ranked, and then the average of those ranks is compared. So for the no group, the average rank is smaller than the average rank for the yes group, and that's what the Mann-Whitney U is comparing. So I scroll down to the third box, and notice that there are several lines of text here, and the first one is the one you're interested in, the Mann-Whitney U test statistic. So you have 38,765.000. That's your Mann-Whitney U test value, but the important thing here is the probability value, and the probability value is the last line in the box, and that's the asymptotic significance, the two-tailed probability value. So the two-tailed probability value is 0.172, but we have a one-tailed hypothesis, and our hypothesis was that people who are chosen for jury service actually make more money, and that was supported in the bar graph, and it's actually supported by the mean ranks here. The mean rank is higher for this group than it is for that group, and so descriptively it's there, but is it as a matter of inferential probability test? And the answer is no. So to answer that question, we need to take that 0.172 and divide it by 2, and when we do that, we get a one-tailed probability value, and that one-tailed probability value is going to be 0.0851. So 0.172 divided by 2 should give you 0.0851, and so that value is actually higher than our traditional alpha level of 0.05, and when it's higher than 0.05, we actually accept the null hypothesis. And our research hypothesis was not supported here. And so people who serve on juries don't make any more or less money than people who aren't picked for jury service. That's our null hypothesis, and that's the one we accept going forward based on the results here.